Okay. So what I'm going to talk about will be very different from Roberta was presenting. I'm going to tell you a story or a recommendation what to do if doing ontology were like coding. So the idea is that, of course, doing philosophical or applied ontology is very different from computer science, but there are some similarities. And because of the similarities, there are some problems that you may avoid. There are some tools that can help you avoid these problems if you just look at your ontology as a piece of code or as an informational artifact, if you like. My agenda for today is that first I would like to speak out a caveat. So where the thing that I'm going to tell you is not relevant at all. And then I would like to expand a little bit on this idea of ontologies as text or as files. And then a few words about version control for ontologies. And finally, what are the benefits of having or developing what is called development and operations tools for applied ontology. So again, in a nutshell, it will be a kind of a talk about possibility of computer support for ontology development or computer-driven assistance for ontology development. So first, what this talk is not about. So if you are developing your ontology by yourself, so if there's just one developer, one ontologist, then probably you don't need any version control or any DevOps infrastructure. Also, if ontology is narrow or small, you have 1 or 2 or 5 primitive predicates, then probably this is not also for you. And if you get it right the first time, so if you just create an ontology and that's it, and your ontology is perfect the very first time, that's also not needed. And finally, if you don't make any mistakes, so probably if you are a computer agent doing ontology, then again, you don't need this whole fuss at all. But in other cases, and I think it's a rather a rule than an exception. I think it might be beneficial for you to consider various possibilities of supporting your ontology development with various computer tools that were developed outside knowledge representation or ontology. They were just bog-standard tools for software engineering or simply coding. The whole sort of thing, the whole story starts when you start thinking about your ontology as a file, as a piece of text. And then you may think about your ontology as an OWL file in various serializations, which, by the way, each serialization is different from the point of view of the computer, or common logic files, or TP files, or some other kind of computer readable files. So if your ontology is just a set of axioms written in LaTeX, probably it's not so easy to support you with development of ontology. But if you have your ontology in some computer readable format, then there are various options that can help you improve your ontology. So first, version control. Since I think any ontology of a significant size grows in time, and it's not just one. It's not created at a given point in time, but it evolves in time. I think one of the very first requirements for its development would be to have some kind of version control. And using, for example, the property our version info might not be enough if you want to first be aware of history of ontology development, but also if you want to expose or present the history of ontology development with all its successes and pitfalls. And if this ontology development is to be transparent, then it's sort of easier to do it using the proper version control for coding than just using things like OWL version info. Also, if there's a possibility that at a given point in time, you might want to consider alternative versions of your ontology, then using some standard tools might be beneficial for you. And finally, if you want to know who did what, and if you want to manage this sort of authorship process, then the use of version control might be needed as well. Also, there's another set of issues when an ontology is, as usually the case, developed by a team, not by a single ontologist, but a team of ontologists. Then you probably need to control access to the ontology. So not everyone has the same privileges of changing the ontology. And if you have these parallel versions, you might want to resolve, or at first identify and then resolve conflicts between these versions. And finally, I think it goes to the first point. If you want to have this control access to the ontology itself, because there are multiple developers in your team, and there might be some conflicts there. And that's the most important point in this slide is there are various tools for version control, bog-standard version controls for code development. I just listed here 4 of them in the alphabetical order, but there are, I think, like 20 or 30 of them. Personally, in the project that I'm currently involved in, we are using a Git application with GitHub platform. And in addition to that, so this is a sort of the first bullet is about the technology, but on top of it, we also try to modularize the ontology, not following some conceptual or logical rules or principles, but simply to have this huge fiber ontology in small chunks, small pieces, so that we want to minimize the risk of version conflict or huge differences between versions. So this modularization is driven not by ontological considerations, but is driven by this considerations related to version control. If we had the whole ontology in one file, a change in one place might confuse the version control tools, so that the benefits of using these version controls tools will diminish. So it's a modularization related to version control and not to the content of the ontology, or not so much to the logical independence between various modules, but modularization driven by our need and wish to smooth the version control for this ontology. This point about modularization is related to a general problem with version control tools that were developed outside knowledge representation domain or applied ontology domain. And the general problem is that for coding, code is usually directly rendered as a text by the developer, and he or she has the full control over it, and he or she can format in a way that they find useful, readable, or somehow optimized. In the case of, for example, OWL ontologies, this ontology development usually happens with the help of some OWL editor, like Protege or TopRate or some other editor. And then when you develop your ontology using this editor, you lose some control over the way that this ontology is written to a file as a text. And this creates a possible trap for version control tools, because if, for example, one developer uses Protege and the other uses TopRate, these two tools will serialize or will write your ontology to these two different files in a different way. And then the version control will show you a huge number of differences between these versions, although the difference might be very small or even zero. So if you open an ontology in Protege and save it in Protege, let's say, and if you open an ontology in TopRate and save it to TopRate, the resulting files might be so different that it would be very hard, the differences would be very huge. So it sort of defeats the purpose of using the version control. So if you want to handle that in a proper way, well, one option is, of course, to persuade every developer in the team to use the same OWL editor, if possible, and probably the same version of the editor, just to be safe. And another option is to have your own tool that would write the ontology to the file in exactly the same way. So it would be a sort of a plugin to your ontology editor that would guarantee that every ontology editor would write the file in exactly the same way. Okay, and the final and probably, at least for me, the most interesting part is to use development and operations tools for ontology development. If you do your ontology as a computational ontology, so if it's or either an OWL ontology or a Cliff ontology or TP ontology or ontology written in a Prover 9 syntax. So if your ontology has a version and let's say has a canonical version that is computer readable, then on the one hand, you have, I think, better possibilities, or you have more capabilities to check the quality of your ontology. But on the other hand, these tools, so OWL editors, common logic editors, or common logic reasoners, or Prover 9, would find any very tiny error that you can make. And as the history teaches us, it happens more often than we think. So in that case, if you have this computational ontology, so an ontology written in some kind of computer readable language, then it is almost, well, it's not a must, but it's it would be good if you could check every time you make any change to your ontology that this change does not diminish the quality or the structure or the, I don't know, outlook or the content of your ontology in the way that you don't want. And sometimes it's possible to, to forget about the bracket, or forget about an axiom and put an axiom that is in consistency with one of the previous axioms. And then the whole point of doing ontologies sort of breaks down. And then it's possible, or there are possibilities of maybe not using, but developing these DevOps tools that could check your ontology development in such a way that any change to your ontology will be scrutinized by a series of tests, and then you can be sure that at least syntactically and to a certain degree semantically, there are no new problems that your change introduced to the ontology. Yeah, and syntactic mistakes, simple things like missing or surplus brackets. Well, the second bullet is also kind of simple, but it happens, or it may happen quite often, that you have a reference to, so you have a set of modules, and each module has a name, as a location, and at some point you change the name of the module, change the location of the module, but you forgot to change the reference to this module, and then the whole system in a way breaks down or is not as useful as it was before that. Or you can, when you are doing, let's say, I don't know, an OWL ontology, you can put a trailing space in front of a string, or you can put a trailing space at the end, or you can put multiple embedded spaces in the middle. And then for human readability, it has probably no impact. But if you try to match such strings, in particular the last one, you may be surprised by things that do not match, and sometimes it's expensive in terms of time and human effort to identify such problems. Or you can, put values to your ontology that are outside value spaces. So, and there are probably many more such syntactic mistakes. And of course, there are also there's also a possibility of semantic mistakes, like adding an axiom that makes your ontology inconsistent, or at least making one of your predicates unsatisfiable, or that's also a possibility. You add an axiom and then you have a theorem that you don't want to have. So in a way, your change to the ontology introduce this sort of boo-boo, ontological boo-boo, if you like. There are also pragmatic mistakes, or something that are called pragmatic mistakes. And an example of that is something that I personally called wet ontologies. This wet ontologies is related to the dry principle that is known from data management or computer programming. Dry principle is don't repeat yourself, and the idea is that it started in the realm of coding, but now it's sort of extended also to data management. And the idea of this dry principle is that you shouldn't repeat either code or data in many places. So suppose that you have a method, a function, and then you discover that part of this method or function can be used elsewhere. So you just copy and paste this loop or something to a different location, and then you have the same piece of code, or in the case of data, the same piece of data in two different places. And if you want to change, and then if you change one of them, you may forget to change another, and this invites a lot of problems that are usually hard to debug. So you may have a similar situation in the case of ontology. For example, one possibility that comes to my mind is that suppose that you have your ontology in Cliff, so in common logic language. This is your canonical language, and then you have also, for some reason, translations to OWL, say. And if you don't do these translations automatically, but just from time to time, every Friday or something, then you may end up with inconsistent versions. So in the sense that your Cliff ontology is different from your OWL ontology. And the reason or the source of this problem is that in a way you repeated yourself, and you created a possibility for inconsistency or maybe incongruency in this case.
Paweł, it's 20 minutes already. I'm sorry, I didn't say the 70 minutes loud enough.
Okay, so maybe I will just say about the last methodological mistake. There are various methodologies of ontology development. And for example, one methodology may require that every OWL class should have as class definition, but you know, in the hurry, you just forgot to add this definition, and then you forgot about the class, and you have this class without a definition. So your ontology doesn't follow the principle that you wanted to follow. And this is why these applied ontologies, in my view, need some kind of automatic verification tools, so that you can be sure, as far as the tools allow, that your ontology is top-notch. Thank you.